Hello and welcome to Mateo's Math. I wanted to do this video just to compare something, two integrals, so you can at least know sort of what I'm talking about. I have this circle. Can everybody see it's a circle? It's it's almost a circle. Well, I'm gonna call this a circle and we can call it a pie if you want. Let's chop the pie into some pieces so we can eat it, okay? Come on. So I have this pie. I'm gonna chop it in half, okay? Let's go chop this thing in half. Come on, in half. Half, buddy. 2 halves. Pretty simple, huh? Oh, I dropped a half of the pie. It's for you. All right. But I have 2 pieces of pie right here, and I'm gonna cut each of them in half again, okay? Hang on tight. Showing you something. I've obviously got a point here. Now there are 4 slices. Let's cut it into 8. Right? Come on, 8 slices. Cut all of them in half. Now we got 8 slices of pie. And that's all I'm gonna cut it because I want to show you something. If we rearrange these slices, we'll get something very interesting. All right? So we have, nope. All right. If we arrange these back and forth, as you can see, like this, you can see it, back and forth. Let's add another slice. I'm gonna show you this. Let's add another slice on top of it. And then another slice. And then another slice. This is a 4th slice right now. And then the 5th slice. Then the 6th slice. And the 7th slice. Then the 8th slice. Alright, there. See if I can pick this up to show you guys. If you can see it here, look what it's formed. It's formed almost a rectangle in this spot. It's slipping off, but it's a rectangle. And if we, it's not a perfect rectangle, but if we keep on cutting up that circle into, like, how about let's do infinity pieces? We'll end up with so many pieces that we can form a perfect rectangle out of it. Pretty neat, right? I didn't actually glue all those pieces together. That would take forever, but it's a perfect rectangle. And for this rectangle, we have our length. Remember, we had we cut it along the radius, right? As we keep on cutting each slice in half, it'll cut along the radius. So the width of the circle would be the radius. Get it? And then the length of the circle would be half of the circumference, right? Because the other half is on the other side, right? And this is the only spot where the circumference is. So it's here and here. And the circumference is 2 pi r. So half of their circumference would be pi r. And look here. Pi r, r, and you know that formula. pi r squared, the all-famous formula for the area of a circle. Done with the concept of integration. Pretty neat, right? Yes, I know. And that's exactly what integration is like, in case you didn't get it earlier. Chopping it up into an infinite amount of slices and calculating the area of each teeny weeny microscopic slice that isn't even half the size of an atom. Exaggeration. Oh. It isn't even half the size of an atom. Well, they're really small, and you calculate the area of each of them, and you sum them up with an integral. That's sum and integral. The integral is actually the sum of those tiny slices. I'll see you in the next section, where we'll actually get into the concept of integration. You're probably wondering how you can actually do integration. I'm going to show you.